Welcome to the video. We're going to be looking at some tricky questions for potential dividers for A-level physics. The first thing is we need to read the information that's given carefully. So the battery in the circuit has negligible internal resistance. So what that means is we don't need to worry about internal resistance in this question. We can just put that aside. And the question is going to be more about our knowledge of just basic circuit rules and resistor combinations and potential dividers. So we've got these two in parallel. We can simplify things down here by calculating the effective resistance of those two resistors combined together. So we know the rule for parallel resistors. 1 over R total equals 1 over R1 plus 1 over R2. And then put the values in, so 1 over 200 plus 1 over 200. Make sure you write 1 over RT there because it's easy to just write RT and forget that you then got to invert it. So 1 over RT, R total equals 2 over 200, and so R total equals 200 over 2, which is 100 k ohms, kilo ohms. Right, so we've got 100. We can replace these two 200k resistors with a single 100k ohm resistor. That's the effective resistance of those two 200k ohm resistors in parallel. We know in general that when we have two resistors of the same value in parallel, the effective resistance is half of the value of just one of the resistors. And that's because you're always going to be dividing by 2 here in this using this rule. So what we can then do is just sketch the simplified circuit. So you've got a 200k resistor in series with a 100k resistor, and we've got 12 volts across in total across both resistors. We know that the PD will be shared across the resistors so that the PDs add up to 12 volts. We also know that the larger resistor will have a greater share of the PD, the greater share of the 12 volts dropped across it, and in fact it will be in the same ratio. So the share of the PDs will be in the same in the ratio of the resistors, and we can see we've got a 2-to-1 ratio here. So we can then look at this and think, well, that's a 2-to-1 ratio, so 3 parts with 2 parts across there and 1 part across the 100. So that's going to give us each part is 4 volts. So 2 parts across the 200k and 1 part across the 100 ohm k ohm resistor, so that you can see the PDs are in a 2-to-1 ratio, just like the resistors are there, and the PDs add up to 12 volts. So a slightly more formal way of doing that, if the values weren't quite so obvious, which they may not be, would be to use the equation V out equals V in multiplied by R2, which is the one that we want to find the PD across. We'll say it's the 100 there, over R1 plus R2, which is the total resistance of that series circuit. So V in is 12 volts multiplied by R2, which is 100k over 100 plus 200. We don't need to worry about the k's because they will cancel out there. That's going to give us 100 over 300, which is a third. So it's going to be 12 volts multiplied by a third, which is 4 volts. So that's, if you like, the more sort of formal way of calculating the value that we already managed to find from our knowledge of the ratios there. So the answer is B, 4 volts.